Hello, everyone. So thank you for attending that session. I hope you enjoyed the keynote from Apple. So now that you know that there's an iWatch, it's really a surprise. You can focus on Groovy and traits. Let's start. So just a few words about me. For those of you who don't know me, so I am employed by Pivotal to work on Groovy core. So I am, for example, the one to blame for the static type checker, the static compilation stuff. Thank you. The new template engine, etc. And in particular for this talk, I implemented the traits feature in Groovy. So if you have questions, this is the session where you can ask about traits. I can't say if I will be able to answer all questions, but if you do have questions, do not hesitate. And of course, I'm a member of the French team, so you have my accent now. So let's get started. Just with a reminder about blogging or tweeting, whatever you want. If you find tweets about Groovy, please use the GroovyLang hashtag, because otherwise what you get is lava lamps. That's interesting. That's not the question, but that's not the Groovy we want. So if you use GroovyLang, you will find those kind of tweets which are related to Groovy. And speaking about Groovy, so Groovy is an open source project. You can participate. You can participate in the roadmap if you want, if you have features that you want us to integrate, if you have features that you already have implemented in your company, whatever, and that you think would be good to have in Groovy, we're very open. I mean, all the project is on GitHub, it's Apache license. Really do not hesitate. We love help from you, from the community. So yes, as of now, we have more than 100 contributors. So it's pretty impressive for, I would say, language, because yes, digging into the language is not the easiest project, open source project that you can get into. But what is nice with Groovy is that you have the Groovy part, the language part, for example, with the classes, the traits feature, etc., which are, yes, really language, syntax, etc. But we have the APIs, all the enhancements that you find on default Groovy methods, etc. Those are API enhancements that are much easier for you to participate in, so do not hesitate. So before I start talking about traits, I would like to know how many people in the room are familiar with Groovy. Raise your hand. Okay, excellent. Maybe some of you do some Scala? No? Not a single one? Impressive, that's good. And yeah, Scala has traits. So maybe you know what traits are from the Scala language. Not at all. Anybody knows what a trait is? Okay. Do you think that Java 8 has traits? We'll see. Okay. So life without traits. What is life without traits? Basically, I tend to say the life without traits is the life without static type checking issues. Traits are really important as soon as you have a static type checker. Why? Well, before Java 8, what did you do if you wanted to call a method? The main aspect of Java is to define contracts, actually. You have that notion of interface. Interface is central in Java. An interface is something that defines a contract. And this contract basically says, I accept this message as an object. And a message is a method call with some arguments. So within an interface, you can define a contract which is common to multiple classes. Okay? That's interesting to have contracts. It allows you to call methods on different types of objects which implement that single interface. That's cool. But the problem is, what if you want to have a basic implementation of that interface that you want to share? The answer, in general, is an abstract class. OK, that works. But what if you want to share multiple default interfaces? Multiple interfaces, multiple implementations. And you have multiple abstract classes? Can you do that in Java? No. You face the famous multiple inheritance problem. Right. So you can define the behavior through abstract classes. You can define contracts. That works in Java. That works in Groovy, but Groovy is a bit smarter because it accepts duck typing. And if you are in a dynamic world like the basic Groovy world is, you don't have that problem. You don't have to define that contract explicitly. You can drop the interface. You can drop the abstract classes. Just have the method existing on the objects is enough. So it is designed by capabilities. Basically, the simple fact that you have a method called foo on an object lets you call it duck typing. So Groovy is a bit better than Java with that regard. Still, we have the problem with those multiple abstract classes. So even if in Groovy you have abstract classes and duck typing, you still can't inherit from multiple classes. Groovy has the same problem as Java. Right. Second problem, how do you know if a class implements a contract? In Java, how would you do that? Anyone? Yeah, you can do basically you do instance of. If foo instance of, then you know that the class implements that contract. You can do the same in Groovy, but it's not very clean. As soon as you start using instance of, you know that there's something wrong in the code. You know. Okay, there's something leaking into the method, something leaking into the flow of your code. So even in Groovy, you have that problem. Well, in Groovy, you can do mixin. How many people use mixin? OK, are you happy with the mixin? No? You shouldn't. If you are, you shouldn't. So mixin is deprecated in Groovy 2.3, and why? Just because we have now traits. So if you used to use mixin, you can replace it since Groovy 2.3 by traits. So I'm going to show you how you can do that. But basically, the idea was that you can have a class, which is a cat, and another class, which is totally different. I mean, a YouTube dog. So a dog, yeah, it will bark. I won't do the sound, excuse me. But so YouTube dog, and what if that YouTube dog could meow? So behave like a cat. I want to do that. OK, so I do mixin cat. And then I can call both the meow method and the bark method on the dog. I have just mixed two distinct classes into a single object. So does anyone have an idea what the problem is with that? It seems OK. But behind the scenes, there are multiple things happening. You have a compile time transformation in action, and you have multiple objects created, plus meta classes created for both the cat, the dog, and the mixing. So you have lots of dark magic behind that. And that dark magic basically is broken. So you have lots of problems with mixing. So if you go to the Jira bug report system in Groovy, you would see that you have actually lots of bugs reported on mixing just because the approach works for simple cases, but you have some problems. And an illustration of that problem is that how do you make the difference between the two instances? So here you have a cat, you have a dog, and actually the mixing creates two instances. And it just allows you to call one and the other transparently, but still you have two instances of those objects in memory. So you have to know whether you are in one object or the other when you want to call a method. So you have some problems, very weird problems that can happen. So it works, but it's kind of buggy. Another problem is that I said that you have one object for the cat, one object for the dog, plus meta classes. So for a single mixin, you have lots of objects created. So you consume a lot more memory than you should for a simple feature like that. Okay, so what would you typically do in Java to emulate some kind of multiple inheritance? If you had to do that, what you would do? Static. Yes, that's an option. Delegation, that's what I wanted to hear. So the easiest one is delegation. So delegation, especially nowadays where we talk a lot about functional programming, etc., you see that delegation is promoted much more today than it was before. So that's true, but I think that delegation is over-promoted just because of the limitations of the languages, especially the limitations of Java. So you can do delegation. So delegation allows you to keep every concern separate. So you have all your objects, and you can keep the features in each object. So you have, for example, my dog could have a delegate, which is the cat. That works, but why not the opposite? Where? Okay, so often the question is, where should I use delegation? Where should I use inheritance? Normally the answer to that question is, can you say is a? If you can say foo is a bar, then the answer is inheritance. And if it's not that, often it's just composition of objects, so you use delegation, right? So to me, it looks a bit strange to use a model like delegation to emulate multiple inheritance, because you want to say is a, but you can't. Is that right? Okay? You can't do that. So still, if you want to call those methods, you have to define interfaces for every object that you want to delegate. So it's not only delegation, you have also to define explicit interfaces so that you can call those methods. Is that okay for everyone? So an example. In Groovy, how you do that? You can create an object which is stack only, which would do what the Java stack does, but doesn't have all those extra methods that just come from inheritance. And I want a real stack. I don't want a stack that can add something at the first element, etc., because why should I have those methods? They don't belong to the contract of the stack. It's just an implementation detail that you inherit, for example, from list to implement a stack. So I want to create a real stack that only has a push and a pop method. That's all. So I create a delegate, which delegates to the real Java stack. I don't care what it does. But my stack will only expose two methods, push and pop. Very simple delegation mechanism. In Groovy, you have actually an AST transformation. Anyone doesn't know what an AST transformation is in Groovy? Not good. So you have the delegate annotation that allows you to do the same just by annotating this property. So I can say delegate interfaces equals false. So this is important. And includes will say I only delegate to push and pop. So why I'm showing this is just to show you that the delegation model is actually appropriate when you want to delegate some methods. And you don't necessarily want to expose the interfaces. You want to expose a subsystem, right? I don't want my stack to implement the interfaces that stack implements. It's not what my API should look like. I would like it to expose two methods, push and pop, and that's all. So delegation allows you to do that. So delegation is fine, but it's still not what I want to do. Okay. So I can try to do some kind of multiple inheritance with delegation, but really not what I want to do. And in Groovy, there is something that looks like what I want to do, but it's not yet that. So it's extension methods. So if any one of you were at the talk from Venkat this morning, you probably know what extension methods are in Groovy. Anyone doesn't know? Okay, so typically URL.getText in Groovy is a method that is added to the URL class. Okay? So the idea is almost the same. I have a class, and I want to plug some behavior inside that class. The difference is that I am modifying an existing class. So in Groovy, we enhance the URL class to add one method, which is getText, with an encoding. So it's quite nice because it allows you to plug new behavior to classes for which you don't have any control. So typically, you don't have control on the classes of the JDK, but you can add new methods to those classes. It's quite interesting. It's compatible with static compilation in Java, in Groovy. So those methods are known to the compiler. Very interesting too. But those methods are not visible from the Java side. And one of the main features of Groovy, especially in the JVM, it's pretty unique. Groovy is probably the only language that has a smooth integration with Java. So you can call Groovy from Java and Java from Groovy. It's very easy to do that. It's the same class format, etc. The problem is that if you use extension methods, those are not visible from Java. You can't call URL.getText on Java code. Actually, you can do that if you know where this method is defined, and you call the static method. So it's a bit hackish. You can do that. Right. So we have multiple options: extension methods, mixin, delegation. Any other ideas for you? Yeah. We didn't find any more, so we needed really something new. But while we were thinking about that, the Groovy team was thinking about adding traits to the language for a very long time. And during that time, something happened. Something happened in the Java world. Java 8 came in, finally. And what they did, default methods. So the name changed several times, actually, in the history of Java 8. It was used to be called Java virtual extension methods. And the virtual is very important. Actually, it's one of the most important details to determine the difference between those methods and the one that we will have in traits in Groovy. So default methods, it's much easier for people to understand what they do. In an interface, you now have the right to add code. Boom, they just destroyed the language. I mean, it's really that. For years, they have said interfaces should never have code. It's a contract. And what they do now, okay, it's not that a bad idea to add code to interfaces, actually. And if they added those methods inside interfaces without default code, then they broke all the backwards compatibility of Java. So imagine the code Java in the wild. How much lines of code do you have? Everything broken because you miss implementations. That's bad. So they decided to do that just to have new methods added. And if your class doesn't implement it, it's not a problem because it has a default implementation for free. So it's pretty cool. So you can declare an interface. So this is Java code. You can recognize it because there's a semicolon and the system that out. So this is Java code, and the Java code says, okay, the default implementation of the greet is say hello. But you can already use that in Groovy. That's pretty cool. If you do class default greeter implements greeter, done. You have it. So it works. You can already use Java 8 features in Groovy. But you can't write that. So Guillaume talked about that a few minutes before. So we will probably do that in Groovy, I don't know, Groovy 2.5, maybe Groovy 3, I don't really know. One of the problems that this needs JVM support. So if you write this in Groovy code, you will have to use the Java 8 format for the class files. So you will not be compatible with earlier versions of Groovy. So the default methods in Java 8 are actually stateless. And if you have ever heard about the infamous diamond issue, if you don't have state, you don't have the problem. Okay? It's not a problem to have multiple interfaces defining the same method because you don't have implementations. And even if you have an implementation, as long as the implementation doesn't access some state, this is something inside the class, whatever, you don't have a problem because everything is well placed. You know? So no state in Java 8 default methods. And virtual means that when you call a method, it looks up a virtual method table to determine what will be actually called. And if you override that, this method is implemented. So this method will be called, not the version from the interface. That's pretty natural, okay? You just do Java like you used to do. The only difference is that you have a default version of the method if you want. So it's fully backwards compatible, and it's quite interesting, but it has no state. Okay, in Groovy, we will do something which is very similar, traits, but we will be stateful. And then you're thinking, okay, it just said that if I'm stateful, I have the diamond issue. Well, we'll see. So actually, some people say that Java 8 default methods are traits. It is some kind of trait. It's just called differently, but it's already some kind of trait. It's a feature that you have for free. So, traits in Groovy. First of all, we introduced a new keyword in Groovy 2.3, just for that. But why to use Java 8 default methods? Well, you have to use Java 8. How many people use Java 8 already? You're lucky. So not so many people already use Java 8. So before we see Java 8 in production, well, it would take some time. Traits in Groovy work on JDK 6, 7, and 8, of course. So you have that feature available in production-ready JDKs. It's not a problem. Traits in Groovy are stateful and composable. And this one is kind of funny to explain. So the trait. Here we go. Flying. Okay, so the talk is named Rethinking API Design. I think it starts with naming. Flying describes an intent. So you're describing in the name actually a capability of your trait. I think it's very important. Naming is very important. So for traits, I would tend to use that kind of name. Flying. Say something that can fly. Something that can do something. So something that can fly will have a method called fly, returning I'm flying. And since we like duck typing, we will have something quacking. In quacking, we'll have a method named quack. So the duck is able of flying and quacking. So this is why we implement the flying and quacking abilities. So this is the key concept. You have abilities that you will compose into an object. This is a very different mindset from what you used to in Java, because Java dropped that feature of multiple inheritance for a very good reason. I mean, it saved a lot of time, debugging time, to millions of Java developers not to have multiple inheritance. But sometimes you would like to do that. Even if you know it's wrong, you'd like to do that. As soon as you start thinking about capabilities, it feels better, you know? Okay, I have some features. Let's compose them, and voila, I have my object. So, basics of trait. In this case, I can see that it's a regular Groovy class. I can add the compile static annotation, and it's still compatible. So for those of you who are using compile static or type check, whatever, don't worry, it works. It's very important. And you can, of course, do the same thing as you would do in Java, which is overriding methods from the trait. So for example, here, if I want to override the fly method, which is defined in the flying trait, I can do that. Just use the override keyword. Well, it's not mandatory, but I suggest that you do that. Use override. And then you can just override that and have a method called fly, which is also called quack. So the duck flies quacking. Okay, it's okay. But yeah.
So in this case, since fly only has one method, which is fly,
yeah.
does this now
it is implementing flying, but you totally forget about the fly method. So this is interesting because internally, it is still an instance of flying, so you can consider trait as an interface. And if you look at the trait from Java, it will see it as an interface. So that's an interesting point because there is. There is. But what we really wanted in traits actually is having that capability of adding features, but we want it to be stateful. And why stateful? Because capabilities require state. At some point, you will need to have some fields, even if they're private, whatever. You need to carry some state sometime. So, okay, for the functional mindset, you should never have set state. I know about that. It's not the point. You have capabilities that you want to coordinate. So my example here is that, for example, I would define an object which is capable of being geolocalized. So I define a trait geolocalized, and it has some properties. And those are regular Groovy properties. You just define a double, and a string. And then I can have a city, and I'm saying, okay, the city is geolocalized. So it implements geolocalized. And what I can do now is using the Groovy constructor as usual with those properties defined. Yes. What if I want to make those properties immutable? You would have to make them private, and you provide your own constructor. Yeah, you would have to create a constructor directly in the city. There's a point about using immutable that I'm going to talk later. So this is the basic. But what is really interesting is that actually what you want to do is compose multiple traits into a single object. So you can have multiple traits carrying their own state. So now I have a trait saying inhabited, just to be able to carry the number of inhabitants. So if it's a city, I can set now that it's geolocalized and inhabited. And now I have this property available directly to the city. So I can do latitude, place name, and population is now available. Is it cool or not? If it's not, I can stop now. I think it's pretty cool to have that feature. Because it solves a lot of problems, you know. You can have orthogonal features and share that code. This is really important. You share code among objects that you don't know about before having to implement them. So what does it tell us? It tells us that traits can be designed as capabilities, as small features, small bricks. So for you who have children and they play Lego, you know, you have small bricks, you compose them, and you have a big object. This is exactly the same. You compose behavior, you compose your objects with small bricks. So one of the biggest advantages of traits over interfaces, over abstract classes, etc., is that you naturally increase the ability to share code. So sharing inside the project, but also sharing outside of your project. Sharing as a library. You are sharing behaviors, and then you can compose those behaviors. So let's go a bit further. What you can do with traits, unless there are questions so far. All good? Excellent. So trait can inherit from another trait. Why not? I mean, I can say, instead of defining the name directly inside the geolocalized trait, I could have an existing trait which would be named, defining a named object, and then saying that something which is geolocalized requires a name, whatever, even if the example is not perfect. Well, then you are allowed to do that. It's not because it's a trait that you can't use the usual inheritance rules. The only limitation is that you cannot inherit from an object. You have to inherit from a trait. You can implement interfaces. You can also have abstract methods, for example, in a trait. It's perfectly okay. Yeah.
Presumably we'll answer this question later, but what's the advantage of opposing traits versus just inheriting all the traits onto the class?
Versus inheriting all the traits.
They say implements, let's say localized and
Okay.
named.
Yeah.
That's on the city versus
It really depends on your model. I mean, it's just an example, but you could have composed and have geolocalized, named, etc. It just really depends on how you think your objects should be, what features you should have. Yes, maybe this isn't the best example, because why would you actually assign a name to something which is geolocalized? Yeah. Does it belong to that object or not? That's arguable. I would say that's the good kind of questions that you can have, because
If geolocalized reference, then you can use inside name, certainly. This method, implement geolocalized name. Because then
yeah,
your dependency isn't shown.
yeah. You could have actually, yes, a method referencing that, yeah. That would be a good reason to do that. So in the first example, I was using the extends keyword. This is my personal preference. If a trait inherits from one trait, I use the extends keyword because I like the fact of having extends. But if you have multiple traits, you need to use the implements keyword. So this is kind of just a limitation of our grammar, actually. So maybe in the future we'll support both. But just know that if you have multiple traits, you have to use the implements keyword. Yes. Yeah.
So the statement was, if I'm going to utilize the name, then I should extend name, but I could have just as well implemented name and still be able to access the name.
Yes.
So that kind of takes off the argument that there's
Yes, it's just that you can replace extends with implements. It doesn't change anything.
well, that means that is there any real reason to extend and just
Well, no, see, the original question was, why do we do class city implements geolocalized
Yeah.
common name?
no, I understand that.
Okay.
I'm just questioning all idea for extends.
Right, when it comes to traits, are extends and implements equivalent except for the restriction of, okay, so it's just a war tool?
Exactly.
Okay.
There are absolutely no difference. You could use extend, you could use implements. It's just that extends is limited to one trait. You can't. No. Okay, so this is basically the same. I have a place which is geolocalized and has an ID, and then my city can implement the place. Oh, good. So for your question, so you can have traits defining abstract methods. So traits are like interfaces, but with code. So why not define abstract methods? Okay, if it belongs to the contract, why not? So you can do that. You can define, okay, something which is polite should say thank, but you don't know the name in advance. So you define an abstract method, get name, and then since my class implements that trait, I can add the property name, and now it works. So it's just implement the interface later. Does it make sense? Yeah? You need the abstract, yeah, you need the abstract keyword just because the grammar requires it. It's just, yeah, you could think about, yeah, an abstract class. It's just the same, yeah. But abstract class doesn't define the contract as an interface would, just that difference. Yeah. But it's just that to define a method which is not implemented inside trait, you have to use the abstract keyword. It's just that. And it would probably be easier to read because otherwise you wouldn't have, like in Java, the default keyword that lets you know that you will have an implementation. So with abstract, at least you're saying this is something that doesn't have an implementation.
So in the second case, if the class person implements polite, is that going to, is the compiler going to tell me if I don't have
Yeah.
certain name?
Yeah, it will complain saying you didn't implement the getName method. So the questions you asked me actually were in the slides. So why using the implements keyword? So for me, there are there's something that just inheritance from the Java mindset, which is traits somehow define a contract too. So they behave like interfaces. So it makes sense to use the implement keyword just because they define that interface and they confirm to a contract. From Java, it's also directly visible as an interface. So if you compile a trait and look at the bytecode, just import the library using traits in Java and look at what Java will tell you the trait is. It will tell you it's an interface. Only it won't have the default implementations. You don't know where they are, but they're hidden somewhere. So one important point is this one. So I said that traits were compatible with JDK 6, 7, and 8. So one question you could ask is why didn't we implement the default methods in traits using the feature in Java 8, which is the default methods in Java 8? So the answer is because we wanted to support all the JDKs. We wanted to support JDK 6, 7, and 8, and default methods are only available since the JDK 8. So if you take a look at that interface in Java and implement that, it will complain saying you don't implement those interfaces, those methods, even if you did define them in the trait. Does it make sense to you? So it's really something that you have to know. It is possible in the Java side to implement a class using a trait, but you have to know how actually it is implemented in Groovy. And you have to do some little magic. Basically, all the magic that the Groovy compiler does for you, you would have to do that by hand in Java. So it's probably not a good idea to implement traits in Java. Okay, so those were the basics. So, yeah.
For Groovy, does this support the annotations such as toString and equals?
I will talk about that a bit later. So beyond the basics, we have, of course, with all new features, we have problems. So what are the problems? What if two traits define exactly the same method? So I have a trait worker, and it had the idea to use the run method. And a colleague of yours actually defined a trait which is called runner and uses the run method. And you want to implement both features, so you have a conflict. Which method will you use? So Groovy solves that by telling you the order matters. So the order in which you declare the traits matters, and the last one wins. So in this case, it will say that I'm a runner, because just runner is the last one. Simple rule. And it's the default rule, but actually you can do more. So if I call that who am I with run, it works. And if I invert just the order runner worker, it's OK. But what if I have two traits defining two methods? Both of them have the same method names, same arguments, etc. And you want to choose one method from one class, from one trait, and the other from the other trait. You have a problem because just ordering won't do in that case. So this is this example. Say I have a trait called lucky, defining an adjective which is lucky, and a name, Alice. And another trait which is unlucky, defining adjective, unlucky, and a name, Bob. So Bob is unlucky, Alice is lucky. Oh, good, but I want a lucky Bob. How do I do that? Actually, you can use that super keyword in Groovy. So for those of you who are familiar to Java 8, this is the same syntax, but Java 8 forces you to resolve the conflicts in default methods using that syntax. In Groovy, if there is no conflict and that you are happy with the declaration order, it's OK. So resolving conflicts is optional in Groovy. So you can say, I will use actually the adjective from lucky and the name from unlucky. OK? Make sense to you? Excellent. At the beginning of the talk, I said something like, traits matter if you have a static type checking system. So typically Java or statically compiled Groovy. It matters because you have to call the method, and if it's not defined in an interface, in a class, whatever, you can call it. But Groovy is a dynamic language. So there is no reason to limit the traits in what you can do. And in particular, why wouldn't you be able to define those special methods like property missing or set property inside a trait? That's a very interesting idea, because in fact, you are externalizing some common behavior of your meta protocol inside a trait. So I'm pretty sure you know about the expando meta class in Groovy. So you could do something which is very simplified here. Something similar with traits, saying, OK, I have a trait defining private field. I am allowed to define private field in a trait with values. And it will just say, OK, if the property is missing, then I will get the property from the map. And if actually I'm saying set property, so notation foo.bar equals, then I will add it to the map. So I'm defining a behavior of something which looks like an expando using a trait. And now I can have a class person implementing that expanded trait. And what is fun is that I can do, OK, new person named Cédric. I can check the name, but I can now do .age equals 35. And it works because .age, actually, age is not defined in person, but you just brought the implementation of property missing and set property. So this is set property. set property with name, age, and value 35. And now when I do p.age equals 35, I'm getting property missing. So you've just done something very dynamic with traits. So this is an interesting feature to design actually DSLs in Groovy. So you can use the traits to define some common behavior in your DSLs in Groovy. So this is not limited to existing methods. So say I have a class defining a method called foo, which just prints the class name. And class B that doesn't define anything. And a trait, which is a bit special because actually what it does is having a bar method, and what it does is checking, okay, if meta_class.getMeta method foo, then call it. Okay, so that's interesting. I am saying in the trait, if that object has a method called foo, I can call it. And what is interesting is that I don't have, like in mixins, for example, to define delegate.something. There's no delegate in a trait. Actually, this is the traded object, this reference. So the implicit this.metaclass, this actually is the object that will implement the trait. So the object that will implement the trait has a metaclass, and I can check if it has a method called foo. So now I can define two classes. The first one extends A that defines the foo, the second one extends B that doesn't. And if I do that, it works. It will just call the foo method only on the first object. I think it's a pretty interesting feature, for example, if you don't have access to those classes and that you still need to add new features. Yes? Yeah, yeah.
And then include the has foo trait sub A, for example.
You could.
So would the false foo if available, would it find the foo method?
Yes, because the meta class, it's all static, so it's compiled. It's all static, so you would have the method available at compile time, so it will be able to find it. So the meta class would define it actually. So, for example, it's even more than that. If I did sub b dot metaclass.foo equals and define a method, then it will be called, because I'm trying to do if the meta class exists. So it has a meta class, and it will check the meta class of the sub b element, find a foo method which is dynamic. So maybe the method is here, maybe it's not, but the behavior of what happens is defined inside your trait. Your classes don't have to care about that. So this brings the question of what is this in a trait? So this is a stupid trait. Yeah. I'm sorry, I didn't hear. Yeah.
And you also create, I think I saw this one, a new instance of A, as, and the keyword as, call for with available.
Yeah, I will show an example with as later. So, just to clarify, this is a stupid trait that just allows you to determine what is this in the context of a trait. So this is the major difference with mixins. In mixin, this is always the object of the class corresponding to the mixin. So in a trait, this is actually the traded class. So if I do class me implements with this, and I call this, so yeah, you're familiar with the is keyword in Groovy. So it's the replacement for equals equals, because Groovy treats equals as the method dot equals. So you can do is. So I'm just asserting that actually this is the same object. So you don't have to battle like you did in the past, trying to figure out if you manipulate a delegate or the object itself, and you're pretty lost. And, well, there is a single instance. There is an object of the class me, and it implements trait. That's all. Very simple. So in Groovy, we have that feature of runtime coercion. So on the documentation, we have that Groovy way of implementing interfaces, which is I have an interface defining a single method, then I can do closure as interface and done. I have something implementing the interface. So this is the explicit way of doing things. And in Groovy 2.2, yes, I think it's 2.2, we added implicit coercion. So you can do something which is my listener, and then just assign it a closure without having to use as keyword. So this is pretty neat, and this is why you couldn't use, for example, the Lambda and Stream API in Groovy transparently using closures. So you can call that so an event, and it will implement interface and print the event. It's very, very simple. That was for interfaces. The good thing is that you can do the same for traits, actually. So at runtime, you can have a greeter with the method greet, the abstract method, and what I do here is just defining the missing method. There's a single abstract method, the famous single abstract method type. So since there's a single abstract method, I can define that method, and then I have my greeter. So it's a trait. And then using just that small code, you have a full trait available. Important to understand is that happens at runtime. It is very, very, very important to think about that. I'll show why later. Yes, the slide is a bit big, whatever. If you want to have an object that does nothing, but add superpowers to it and give a name to it. Okay, that's possible, but in classical, even in normal Groovy, what if you have an object and you want to implement multiple interfaces? How do you do that? You can't, actually. You have to use two temporary variables. You have to do my object as interface 1 as interface 2. And then it implements the two interfaces. With traits, you have the ability to do that in a single method call. So this is the old way of doing that. You can do something named, so O as named. So this is where you can explicitly see that it happens at runtime, not compile time, because I'm using a variable here. So it could be whatever object. In Scala, for example, you have the syntax which is new something with a list of traits. And it's a compile time thing. It's very important to see the difference, because here you do something which is done at runtime, so create a new object at runtime, a new class at runtime. So I create a named object, and if I call the do something method, it's missing because I couldn't do as named, comma, superpower. Okay? So what I need to do is a new thing which is powered, let's take the last one, powered do something would work in that case because I'm doing O as superpower, but I'm missing the method from the first one. So you have to use two distinct variables to implement both features. With a trait, you have the method with traits. You just define the list of classes that you want to implement and done. You have an object which is created at runtime that implements both traits. This is the key of a feature that I'm going to show later, which allows you to define new kinds of APIs, actually. Yeah.
Those traits can't take arguments, right?
Those traits can take over what?
Can they take constructor arguments? Like what you were talking about?
No, they can't. You can't have any constructor in a trait. There are reasons for that, but yeah, you can't. There are some limitations. So the coercion occurs at runtime. So what can be surprising if when you wouldn't try it the first time, but actually is exactly the same with normal coercion in Groovy, but maybe you've never seen that. But if you coerce something at runtime in Groovy, I'm doing p new person and coercing it as flying, the object which is returned is not the original object anymore. It's a proxy that implements the new methods, the missing methods, and delegates the others to the original object. So you have two objects. As soon as you do something at runtime, you have two objects. So it's not the original object, but what traits guarantee is that the returning object will implement all the interfaces of the original object plus the trait. So as soon as everything is defined either in interfaces or trait, you're good. Now, in case of multiple traits, you have one proxy that implements all traits at once. So a single object. Okay? So runtime coercion is important to understand because I had a question actually from Eric Pratt, so he's someone quite famous in the Groovy community, and he was telling me, okay, I want to do that, so this is something which is inspired from Scala. So Scala, they have a no-stack trace trait saying, okay, normally if I do this, I can override fill-in stack trace and have fast exceptions that do not fill the stack trace. Because when you throw exception in Java, what takes time is actually filling the stack trace, not creating the object, filling the stack trace. So usually when you don't care about the stack trace, you override that method, fill in stack trace, and do nothing, just to be fast. So you can create an expensive exception that extends runtime exception, this classic exception, and a cheap one that extends runtime exception too, but implements the stack trace. So I'm creating one of this kind, the other of the cheap exception kind. And the last one is actually an expensive exception, but coerced as no stack trace. So reading that code, you could think that the last one is fast as the first one. And it's not. So here are the figures. Actually, the last one is much slower. So anyone has an idea why?
How's the dispatch working on this process? Is it using invoke dynamic?
So no. Even if it used invoke dynamic, it would be as slow. No magic in there. So the reason is pretty simple, actually. When you do that, you have to see this as two distinct instructions. So first, new, then coercion. So you pay the price of creating an exception. Then you pay the price of coercing into so you're doing two things. So it can't be cheaper, actually. So this is why I'm very careful with that kind of lines, because it looks like what Scala does with the with keyword. But in Scala is a static world. It's not a dynamic world, so you can't dynamically coerce something into something else. It's all done at compile time, so they can optimize and create a class that doesn't actually fill the stack trace. It's all done at compile time. In Groovy, it's not the case. You're enhancing an existing object. So you pay the price for both. Okay, so I should hurry up because I have a bit more slides to show you. So I was saying that traits in Groovy, the method dispatch is not very virtual. What does it mean, not very virtual? So far, it behaved exactly like the Java 8 methods, default methods. I mean, if you have an override, it takes the version from Java. That's true. It takes the version from the class itself. So what I do here is just defining a getColor method, which is defined by my trait, and this one wins because it is defined in the class itself, so it's the usual semantics. What is a bit more surprising, maybe, is what you will see here. Surprising, but very interesting for new APIs. You define a class color3 and a class color4 that extends that one, and it implements hasColor. When you do that in Java with default methods, then this method would take precedence because it's a default implementation that is taken, okay? It's all a default implementation, so since there is an implementation lower in the hierarchy, it takes that version. In Groovy traits, it's not the case. It will return red. Why? Because the trait takes precedence. So just because you implement the trait, at the moment you implement the trait, you carry the version from the trait. So this is actually a feature that was necessary in the Groovy code base to replace some behavior that was from mixin. And the typical use case for me was to share some common overrides. So for the type checking, I had test cases. And there are two annotations in the test cases. They are type checked and compile static. And I wanted the same test cases for both. And actually, the type checking test cases add the type checked annotation transparently in the setup method of the unit test. And I wanted to have exactly the same methods, tests, with compile static instead of type checked. So what I've done is a trait that implements setup and overrides what the setup from the superclass does. So what you can do is my test case extends the type checking test case, implements the static compiler setup, and then you're done just with a single line. You inherit the new behavior. Yes?
Does this still generate a class file for the interface?
It generates a class file, yeah. So this leads to the meaning of super in traits. So the basic is that lucky.super.foo calls the method foo from the lucky class. This is the very basic meaning of super. But actually, in traits, you have another meaning for super, which can be used to define new APIs, chaining APIs, actually. So imagine that you have an interface, which is a message handler. Could be a trait with no methods, whatever. And then you define a trait, default message handler defining onMessage. And that says print line, I received the message. This is very basic logging. And it's a trait. Important, it's a trait. Now I can have a class, my handler, that implements that. And then I have the default behavior from the trait. So it will return, it will call actually that method, received message event. Okay, interesting. But now what I'm doing is an observer handler. And what does it do? Actually, I'm observing a message. I can print payload, whatever. But I'm doing this, super.onMessage, tag payload. Interesting. What does it do? We'll see. So define a class that implements the default message handler and the observer handler. And now what happens if I do onMessage is calling this one because the last one wins. So I am printing I observe the message, and then it reaches super dot. And super will delegate to the next trait in the chain. So it will call this method next. So this is one of the features that you will probably use to implement new kinds of APIs with traits, because it really allows you to develop chaining of behavior without having to define all the classes that know how to delegate to the other. Just bundle in the language just with a super keyword. So it's important at runtime, actually, more than at compile time, because you can define a base handler that says, okay, it does the same as the default one, whatever. Something that will convert the message in uppercase. Another one that will call twice. So I have a handler that will actually duplicate my message. And then I can do, okay, create a base handler, and then coerce it with traits uppercase duplicating observer. And what you will do, so first calling this one, which calls super. So I'm going to duplicating, so it will call message twice, and then call this to uppercase, so I should see at last receive the message with the uppercase. Is it clear for everyone or not? Yes?
You would have done another class that implemented both of those traits, or I should say all three. In the super call, you would only get the last one wins, right?
You get the last one, yeah. Or you can, if you're not using the trait in the interfaces, you can call the super class method, which has the same name, for example. Okay, so a few minutes to talk about the gotchas of using traits. So I said that we didn't have the diamond problems with interfaces, and since we add stateful traits, normally we have the problems of diamond. So imagine that I have a trait which is just an incouple and define a sum method. Two properties, very basic. Okay, that works. So if I call the f method, which calls the sum method, then it returns 3. Very natural. Okay? So now, what do you think about this example? What happens? My class defines itself two properties named x and y, and a method that calls sum from the incouple. What is the result? What do you say? 7?
Your stuff overrides the local stuff overrides.
7. If you want 7, you have to write it. It will not. It will use, actually, sum defines those properties. So x and y uses those ones. It uses the fields from the trait itself. So if you call sum, it's the method sum from the trait. So using x and y from the trait. So this is done specifically to avoid the diamond problem. Because otherwise you would have two fields and you don't know which one to use. Two fields with the same name. So what internally Groovy does is when you implement a trait that has state, the fields which are created are namespaced. So you have a field which is named incouple x, incouple y. So if you want to have 7, you have to do get x, get y, to say if someone overrides the getters, then those are the versions that should be taken. But it's the responsibility of the trait to define what should be the behavior if it's overridden. So you avoid the diamond problem using that. So yes, this is typically what you would have if you print the fields defined in the base class, you would see that you have actually two fields named that. So it's a bit internal space. So this is for you to answer the questions about AST transformation. Can you add to string, for example, to a trait, whatever, immutable? The answer is, in general, no, never do that, because most of AST transforms are not compatible with traits. And if they are, it's written in the documentation. So if you don't see a line saying, I am compatible with traits, consider they're not. Or use unit tests to check. So in fact, there are multiple reasons for that, both technical reasons and logical reasons. So the technical reasons are that there are compilation phases, and if you want to have a trait which is defined in the same source unit as where you use it, you have difficulties to mix it with AST transforms. And the logical ones is that you never know actually if you want to apply the AST transformation on the trait itself, or if it will be applied when you apply the trait. And it's a very big difference. So as an example, this one will work, and what it does actually is statically compiling all the code in the trait. So this one works, no problem. This one works too. You can have a trait which is delegating trait, and you can use delegate, and then you have something that delegates to the map. It works. So those are the two AST transformations that work with traits. This one will not. So if you use trait and define a property name and call toString on the class that implements the trait, you would see that actually the toString transformation misses the fact that you have a property coming from the trait. So this is something we are working on. I will also probably write some blog post to try to explain more in detail why it's very complicated to solve. And we will make some decisions at some point, but don't trust AST transformations with traits, basically. Yeah? I have no idea. It should probably work because it's, compile static was very last in the chain, so I expect it to work. Yes? They are carried over the traded class.
What happens if you have colliding annotations on two traits that are implemented by the same class?
Both annotations are carried, so it really depends on the annotation. So it's a semantics problem more than a technical one. You would have both annotations carried. So it really depends on what those annotations are supposed to do. Okay, so I have 10 minutes left just before the questions. A few remarks. So the talk was about rethinking API design. So I think what actually traits let you do is really think about components. Think about those bricks of behavior. Traits let you do some kind of general delegation, but delegation of all methods, actually. So it's the cleaner delegation model that we have explained in the beginning of this talk. Traits are stackable. So this is the last example that I have shown with super. This super keyword is very important in the design of new APIs. And last but not least, even if they're visible from Java, don't try to implement a class in Java using a trait. But it doesn't prevent you from having a method in Java that accepts a trait. You see the difference? You can have a method that accepts a trait as an argument, but don't try to implement a trait in Java. So yeah, the last example that I had was to develop some kind of DSL. So for example, I can do a trait that implements list of string. So if it implements list of string, actually I do have access to the sum method. So I can call the total length, which would compute the sum of all the lengths of the list. And a filtering list that implements also this string, so the same interface. And this one would just filter elements. So one that contains G, the other J. As list of strings, so converting it to another trait. So what I can do now is having a list of elements with traits filtering, and then the filter method comes from there, and the total loss method comes from the coercion here. So you can compose new DSLs very easily with that. So in conclusion, basically we have solved the problem of multiple inheritance in Groovy. You can have those behavior composed, and we solved the diamond problem by using that namespacing strategy. So it comes at a price. It comes at the price that you know that if you're adding some state into a trait, you have to think about how that state will be used. So if it's a state purely local to your trait, or if it should be extended actually. So knowing if you should use the getter or the fields directly. I recommend you to read actually the documentation of the traits. It's fairly complete. I mean, it's a new feature, so the new features are much better documented than the old ones, because we wrote the documentations as the feature was developed. So you have lots of details, and you can also read my blog post about that. And yeah, if you want to just read, here is the address of the blog post. So I have 6 minutes for questions, so shoot. Yes. Yeah. Yeah. Yeah, because traits just behave like interfaces, so you can have flying as a field, and then as long as you put something that implements flying, it works. It's compile time. Everything is compile time, so traits are really compatible with static compilation because it's all done at compile time. So that explains why the methods are visible from Java, for example. I'm sorry? Can I define a property as two traits? No. No, because just, yeah, we're bound to the JVM, and the JVM just lets you define a single type for a field. Another question? Yeah.
Use traits in Java, I know you said don't do it, but if you're willing to implement the interface.
Yeah.
The whole interface, you're okay to do that, right?
You can do that, and then what would it do is just as if you had a class that overrides every method of the trait. I can show you five minutes. I can show you what it looks like when you compile a trait, just to give you an idea what you would have to do in Java. Yes, I have to just quit this one. Okay, so no, I have to launch a Groovy console. It would be much easier for you to read. Groovy console. So I have a trait, foo, and the method name says Bob. Okay, so let's increase the font so that you can read actually what I have. string. Yes. Okay, and whoops, what happened? Okay. So the tool I'm going to show you is the AST browser. Anybody knows what AST browser is? So it lets you browse the AST, the Groovy AST. And what you can see is that actually for a trait, you have an interface which is created. I can't. Yeah. You have an interface which is created, which is the foo interface. And inside, you have a class which is trait helper. And that class contains all the methods from the trait. And what the Groovy compiler does is delegating to those methods. One last question?
Just an observation. I've been studying functional design, but this is the first time I've heard about traits. And it seems to me a lot of the new features that are coming out with OO languages in general seem to try to work with the developer to say, I want to pick this function from this class and this function from this class because they weren't originally designed together.
Yeah.
One class. And what I'm learning from functional is that instead of trying to pick, because once you make a choice with a class, if these functions go together with this internal state, it's done, right?
Yeah.
That's done. So I'm just learning more and more that, like you had the DSL, it was essentially a pipe of your list into two functions. And I'm learning more and more that I think the languages are headed that way more naturally, but I think OO is struggling how to embrace that with backwards compatibility of all the classes that exist.
Yes, that's true, and I would add that actually we're really bound to what the JVM offers. So, for example, all the problems that you have with runtime coercion and having a different instance is just because the JVM doesn't let us modify an object at runtime. So if we could really modify an object at runtime, we wouldn't have that problem. Okay, thank you.